All right, so honestly, it's just kind of the next natural thing to do, and you already did it. That is, we're going to do some application of right triangles. So again, the activity yesterday was an application. It's probably like the most common application, trying to basically find or use some type of right angle. Usually it's the height of something, because most things are constructed at a perfect right angle. And then you get a right triangle, and out pops SOHCAHTOA and all kinds of answers. We're just going to take that idea. We're going to kind of expand on it a little bit, give you some other problems that can use right angles. Also want to give you some terminology. Ultimately, I'm going to give you an assignment. Now, an assignment is more than just like a couple homework problems at night. An assignment is something that takes a little longer. It's graded for correctness. And if you looked up at the board, you can see that we're even going to give you class time tomorrow to basically work on it. I'm going to give it to you tonight so you can kind of get started. That's always a great idea. Do like 3 or 4 problems, and then you can keep working tomorrow. Actually, I'm going to teach you one example tomorrow, basically something that's a little more challenging, but we're going to do 2 simpler examples today, enough to make you dangerous and to be able to get started on that assignment. So, angle of elevation and angle of depression. If you didn't copy them down yet, make sure you do. I want to explain them, and ultimately, let's use them. Okay, now an angle of elevation is a real common angle when it comes to talking about right triangles. It's always made with the horizontal and a higher object. If I were you in my notes, I hope you're not getting tired of it, but I would maybe make a quick sketch of yesterday's scenario again, because the angle of elevation fits nicely into this sketch. So whatever you want to draw, but make a real basic right triangle application sketch. Yesterday's lab is perfect. Okay, because the angle of elevation, that's what you measured. That's what you found when you put the hypsometer up to your eye, or the clinometer. This would have been the angle of elevation. And that's usually pretty easy to see. Again, it's made with the horizontal and a higher object. It's the angle that is measured from the ground, although we don't really say that in the definition, but that's really what it means. It's the angle measured from the ground. Now, angle of depression. Angle of depression. Angle made with horizontal and lower object. Angle made with horizontal and lower object. Let's have a little talk here, because this is probably the most common mistake. And it's not really a math mistake. It's more of just understanding this definition. Students think that this angle is the angle of depression, but that is incorrect. Students think that this angle is the angle of depression, but that is incorrect. Why? You don't need to know anything else except the definition I gave you to be able to see why. What do you think, Grace? Because again, what? Well, no, the object, you're still like looking down at the object. So you're kind of like making it with a lower object. But it does have something to do with the other part of this definition. What's not horizontal? Yeah, and it's kind of wondering how you would explain that, but you're right. The line at the top is not horizontal, it's vertical. Okay, now some people will call that like the reference line, but in reality, the reference line needs to be drawn in. The reference line needs to be drawn in, so that you now can reference that line, and we call that the angle of depression. Angle of depression. Be careful, because when you see it from the teacher, when you draw it in, everybody's like, yeah, it sounds good, but you got to draw in that line. And I'm telling you, in almost all cases, when you're looking down at an object, so you're standing on the light poles, not where I want to be, but you're standing there, you have to draw in that reference line, and you get the angle of depression. Anything from geometry kind of sort of tickling your ear? Anything from geometry about these two angles? They're the same thing is correct. They're equal. Okay, that's always true. You might want to add that to your notes, that the angle of elevation is always equal to the angle of depression. The angle of elevation is always equal to the angle of depression. Nice job, Lucas. You made your geometry teacher proud. Okay, you don't have to have the theorem memorized, but it's two parallel lines cut by a transversal. These are called alternate interior angles. Again, you don't have to have that memorized. If you're like, yeah, I wouldn't have got that. At least understand right now that these two are equal, okay, because of that, basically that simple theory of parallel lines. Let's do a problem. Let's do a problem that actually uses kind of this angle of elevation, angle of depression. And it's the first problem. Okay, maybe look at it a little more closely now. It talks about a lighthouse and a boat. Now, for some of these problems, I'm going to kind of be honest with you. You want to be able to sketch them. Now, I already kind of drew a sketch for you. If you look at the paper, it's got some color and stuff, but you still want to be able to get a simple sketch onto your notes. Don't look up here for ideas on how to make a sketch. Unless you're as good of an artist as I am, then you can certainly steal mine. What I really want you to do is I want you to be able to put the right triangle into the problem. Don't be scared to draw lines. Okay, you can do it. Don't be scared to draw lines. The language is a little fancy, but it talks about basically someone that's up in the lighthouse and they look at the boat. And so that line that I drew in would be that, basically that sight line. It would refer to where someone's looking. Okay, but a right triangle is not that far away. That's why kids kind of like these problems. I mean, it's always going to be a right triangle. Don't be scared to draw it in. Okay, and then you can start taking the information. I know you can do this, but label things. The height of the lighthouse is 250. Now the boat is pretty far out there. Okay, it's about ready to fall off the edge. It's pretty far out there, 2.5 miles. Careful, if you write 2.5 right here, it should be a little something that just doesn't feel right, because of course the units aren't the same. Remember how many feet are in a mile? 5,280. All right, so we have kind of a little extra step. Just got to be awake, got to be aware. And 13,200 makes a little bit more sense. Now, all those things, I would hope that you're going to get comfortable with real fast, drawing in right triangles. The reason we're going over this problem is because the hard part is sometimes figuring out what we're trying to find. We're trying to find an angle of depression. Remember, an angle of depression is always made with a horizontal. Ooh, so we have another reason, and I'm telling you, you always have a reason to do this, to draw in that horizontal line. Okay, because this angle right here in yellow, this would be your angle of depression. I'm just going to label it theta, unless you like putting letters on your sketch. Sometimes people want to put ABC, but we could just call it theta. Okay, so that's what we're trying to find. So now you kind of have to put the thinking cap on. Theta, sketch, right triangles, or maybe something else. In fact, we'll kind of rephrase that from a question to, we can find the angle of elevation. Okay, if you're feeling like that kind of fits a little bit better because it's like in the triangle, I would agree 100%. In fact, it's a lot easier to focus on this theta than to worry about this one out here. So yeah, now to find that theta, got to use SOHCAHTOA. Okay, you got to be thinking a little bit about opposite. Okay, based on the mini check, it looks like you guys, for the most part, have this worked out. So we got the opposite, we got the adjacent. Okay, now that's important because that's based on theta. So this side that's opposite, adjacent, you pick up the phone and you call tangent. So we got tangent of theta equaling 250 over 13.2. Tangent of theta equaling 250 over 13,200. And then, as you guys did a nice job on the mini check, use an inverse. Use an inverse, and you get your angle. Okay. Now, just by the way, when you do this on the assignment, what I'm showing on the board, I would expect you to also show. Draw a sketch, set up the problem. So you need to show this tangent right here. But the rest of it you can just do on your calculator. You don't have to show inverse tangent if you don't want to. Obviously, show the answer to a couple decimal places. Interesting, you get like one degree. Okay, that ship is really far out there. Even if you're standing up on a lighthouse, you're going to feel like you're barely looking down. It's not drawn to scale very well, but it's only a 1 degree angle. What do you think? Okay, just to kind of be honest with you, that's a pretty basic, sort of straightforward, common application problem. Okay, now I want to go over one with you that it's a little more specialized. Like I wouldn't expect you just to like say, hey, Miss Naylor, you're just going to do this. I need to talk to you about it a little bit. It's that next one that has to do with highway grades. We will save the third problem until tomorrow. It'll give us a little quick something to talk about tomorrow. Let's talk about the highway grade problem. In your notes, a highway grade, have you seen a sign like this before? Usually they're on like rather steep hills, often alerting trucks to that danger. Okay, now notice that it's written in a percent. So we've got a highway grade, but it's really written in percent form, yet it's referring to an angle. So let's talk about that a little bit. Wonder why it's written as a percent. Well, it's to get you guys to think about, it's really because it refers to two numbers. Now, to think about percents, you can remember that 6% is really referring to two numbers. It's referring to 6 out of 100. Every time it'd be out of 100. Okay, now you might be saying, well, what's that got to do with angles, or what's that got to do with triangles? Well, in math, when you have two numbers in a fraction form, they always represent the rise and the run. And so you're going to find out that 6 is the rise and 100 is the run of a triangle. Let me show you. Let's get a little sketch going here. We got a road. Maybe we could say inside the road, if I can kind of say it like that, inside the road, under the road, we could have an argument for a triangle that has a rise and a run. What I want you to get from this is that it always works this way. It's always out of 100. And so therefore, these two numbers will always represent the legs of your triangle. Now, they also represent like the slope of this road. And the common question then is to find the angle of elevation of the road. Now, make sure you understand here, the angle of elevation would not just be 6. Okay, if it was, then we wouldn't be writing it as a percent. But the angle of elevation, it would be theta. And so once again, we have a little adventure here to try to find theta. I encourage you just to take a moment and think about SOHCAHTOA and how you would set this up. If it's crossed your mind that it seems similar to the other problem, then that's good, okay, because it is similar to the other problem. In fact, it's the same. You should be getting 3 degrees, a little bit more than 3 degrees, but it's another opposite and adjacent scenario. So it's going to be tangent again. Okay. I don't want you to think everything's tangent, but it turns out that it is. And actually, it's kind of interesting because you're just going to be doing the inverse of 6%. I mean, if you kind of slow down a little bit on your calculator, 6 over 100 just goes back to 0.06, 6%. So you're going to be doing the inverse of that number that would have been posted on the little sign. Okay, but it doesn't equal 6. It actually equals 3. Now, 3.43, is that what you got? A 3.43 degree angle. I don't know kind of what you think, but that would actually be pretty unsafe for a big, heavy truck barreling down the road. Even though 3 degrees might not seem like too much, it would be something to cause some alarm. Okay, now I want to give you the assignment because this is basically what you have to do, and that is be able to take a right triangle and put it into a scenario. Tomorrow, though, we'll do a problem that's a little bit harder. It's going to involve like a couple right triangles. But again, we'll save that for tomorrow. You could probably complete about half of these problems without tomorrow's lesson. Will you do half the problems? That's up to you. Okay, I really encourage you to do some of the problems before you walk in tomorrow. It's always a great idea to get started. You know that usually getting started is the hardest thing.